Hello, and welcome to this OpenTopography video. My name is Chelsea Scott, and in this video, we're going to discuss first what a digital terrain model, or DTM, is, and then we'll discuss how to make one on OpenTopography. So to begin, here you can see an example of a digital terrain model, or DTM, on the left, and the same area, but shown as a DEM on the right. And in particular, in the DTM, you really see the bare earth. So you see the landscape with the trees removed, and this lets you see the details of the topographic relief, as well as the details in the patterns in the rocks. Here in the digital elevation model, you do see the bare earth, but it's covered with vegetation. So we see here trees or bushes on top of the bare earth. And while we can still see the bare earth underneath, we do also see that details of the vegetation. So a DTM is an example of a gridded or raster data set, and it's a digital representation of topography. The fancier term is a raster data set, and this is a grid of squares or pixels. So if you've seen other videos, we've shown this before, and this is a grid of a topographic data set where the elevation in each square pixel is printed. And here we can see 400 at the top, or the middle, top elevation, and zeros along the side. So this is a pyramid. Again, each pixel is represented by a single elevation, and this creates a continuous surface of elevations. And as we've said before, it's important to remember that this is not true 3D, where 3D features such as trees and overhangs are going to be represented by a single elevation. So let's look at, in more detail, an example of a digital terrain model. So to convince you that digital terrain models are important, I've actually started here on the top showing a hillshade of a digital elevation model. And here you see a lot of roughness. And this roughness is created from trees. This is Bainbridge Island near Seattle, and there's a lot of vegetation. And again, that creates this rough surface. Here is an example of that same area, but shown as a DTM. So we can see that underlying bare earth topography underneath, and in particular for hazard mapping, we can see these linear features, and these are examples of faults. And these faults have been mapped, shown here in the bottom, by the USGS, available in the Quaternary Fault Database. So in summary, this is really an important example of showing the bare earth features, in other words, faults, that we can see beautifully in a DTM, but are really hidden in a DEM or digital elevation model. So more broadly, what are the applications of digital elevation models? So they can be used for hazard mapping, as I showed on the last slide. It can be used to map faults, also landslides. They're useful for geologic mapping, specifically for delineating different geologic units via their contacts. For hydrology, DTMs are useful for mapping the direction of water flow. They are commonly used in engineering and construction, and specifically in informing design decisions. And just more broadly, they're very useful for visualizing what the bare earth or underlying terrain looks like with the vegetation removed. Now we're going to get on how to make a DTM on OpenTopography. So here we're going to be looking at a point cloud data set, and I'll show you how to do this on the browser in a second, but just briefly to discuss. So if you select a point cloud data set, then here you have the option to get point cloud data and get raster data. And the fastest way to get a DTM is to select Get Raster Data. And then in window 3, which I'll show you in a second, you will have the option of downloading a digital terrain model. And you can also make a DTM via the Get Point Cloud button. This way is slower, but it does allow more customization. And then in particular, in the first window, coordinates and classification, you'll want to first select standard classifications, and then you'll want to just say ground. And if, for example, some of the more customization could be if you had a very high point density data set, for example, maybe 10 points per square meter of ground points, then you could create a grid that was with a resolution better than 1 point per square meter. So now we're going to go look at OpenTopography, and I'll show you how to do both of these. So here we are at OpenTopography, and you'll want to go to Data. And for this example, we are going to look at this Mono Lake, although you could pick any of these or many red data sets and you'd have the same options. So then you go to select a region here, and then you can draw a box over your area of interest. All right, so here you have the Get Raster Data option. And that's our selected area of interest. And then in particular, you want to make sure that the digital terrain model, DTM, is selected in window 3. And then you can press submit. And then so that was the easy option. The more complicated and slower option is to come here to get point cloud data. And then you can come down here in this first window, coordinates and classification. And then you want to come to standard classifications. So you'll click that. And you may have different numbers of options available, but you want to make sure that you keep the ground classification checked and then uncheck the other classifications. You can press submit. So that concludes our video on how to make a digital terrain model on OpenTopography.